So here we are going to solve another problem on electric field and electric force. So we have got a uniform electric field of magnitude 1000 Newton per Coulomb is directed to the right from A to B. What would be the magnitude and direction of electric force on a positive charge of plus 20 nanocoulomb located close to point A? So there is a charge particle here, charged object kept here in the electric field. Now, the formula which we have to focus on is the one which connects electric field and electric force. So, electric field is equal to force per unit charge. We can arrange this formula as F equal QE, and we have got the value for Q as 20 nanocoulomb, which we'll write as 10 to the power negative 9 times the electric field itself is given to as 1000. So that will give us the answer as 2 times 1, 2, 3, 4. So 10 to the power negative 5 Newton. 2 times 10 to the power negative 5 Newton. You can calculate that in the calculator. Okay. Next, let's look at another problem. Two-point charges are placed close to each other. The charges Q1 plus 2 microcoulomb and Q2 plus 2 microcoulomb are situated as shown in the figure. At which labeled position is the magnitude of electric field 0? Now, you can see that this is plus 2 microcoulomb. This is also plus 2 microcoulomb. They are they are having the same magnitude and the same sign. Both are positive. And we want the net electric field, the magnitude of electric field should be 0. So E net should be equal to 0. You will have E1 because of Q1 and E2 because of Q2. You need to cancel them both. That means they have to point in the opposite direction. And we know that for positive charge, so if I look at point B, electric field at point B because of Q1, let me draw it in blue color, it will be to the right, that is E1. Okay, and electric field because of Q2, let's take another color. So Q2 is also positive charge. It will also point away from Q2, which will be like this to the left. So E1 is to the right and E2 is to the left. So they are opposite to each other. That means B should be the point. At which labeled point? The answer should be B. B is the point where the net electric field will become equal to 0. Now let's just test out. What about C? Are they going to point in opposite direction or not? So if you look at point C, so for Q2, it should point to the right. That will be E2 because it's a positively charged object, and for positive, the electric field should point outwards. So at point C, it will point to the right. And for Q1, focus on Q1. Q1 is also positively charged. So its electric field at C will also be outwards. So let's draw that with blue color, and that will point like this to the right. So that is E1. So what do we see here? Both E1 and E2 are pointing in the same direction. That means they cannot cancel out each other. So that's not our point. C is not the point where net electric field will be 0. Similarly, we can check at point A. Let's do that. So for point A, Q1 is a positively charged object as usual, as it's given in the problem, and the electric field should point outwards, so it will point to the left, that's E1, and our Q2, which is also positively charged, it must point outwards, so it will also point to the left. Let's just draw it and see it. That green color arrow which I'm drawing, that's for E2. So we can see that both electric fields are pointing to the left. They are going to add up because they are in the same direction. They cannot cancel, so A is also not the point. It's only in between the charges. The electric fields will point away or in the opposite direction. one to the right and one to the left. And that's why electric field at point B will be equal to 0. Next let's check this one. Is the statement below regarding the electric field true or false? Let's look at the statement. The electric field is 0 somewhere on the x-axis between plus 4q and minus 2q in the figure below. Electric field is 0. Okay, so first of all, if the electric field has to be 0, if E net because of Q1 and Q2 have to be 0, let's name this as Q1 and this as Q2. That means the electric field for Q1 and electric field for Q2 must be opposite to each other. So we need to check, are they going to become opposite to each other or not? So I'm going to, as we did in the previous question, we are going to draw the electric field vectors E1 and E2 in each section. So let's name this as, okay, let me use the color here. Okay, let's name this as section 1, this as section 2, and this as section 3. We need to check in each section, will the electric field E1 and E2, will they become opposite to each other or not? So let's take a point here in section 1. So Q1 is a positive charge, okay, Q1 is a positive charge, we can see that, it's plus 4Q. And for positive charge, the electric field will point outwards. So I'm going to draw the electric field vector E1 outwards from Q1. It is going outwards. That means it will go to the left. Now for Q2, if we look at Q2, Q2 is negative charge. For negative charge, the electric field lines point inwards. Okay, that means towards the charge. So when I draw E2 in section 1 in this region, E2 will point to the right, that is the direction of E2. Okay, so there is a possibility because these two electric fields are opposite to each other, they can cancel out. Now we need to ensure that will they become equal to each other or not, because we have got different magnitudes. One is plus 4Q and one is negative 2Q. So in order to make the electric fields equal to each other, we need to move away from 4Q and we need to come closer to 2Q, because 4Q is a stronger charge. So we need to be far from 4Q and we need to be close to 2Q. That means it's not possible. So if I name this point as, let's say, point P, at point P, let me use black color here for the point. So at point P, even though the electric fields are opposite to each other, it is not possible to cancel it because E1 will be stronger than E2. All the time E1 will be stronger than E2 because the point P is closer to 4Q. So E1 will be a stronger field. Now let's check the section 2. In section 2, again, to draw the electric field line, I'm going to, let's take a point here Q. So at point Q, the electric field for positive charge, that is Q1, will point outwards. So let's draw it. It will point like this to the right, that's E1. And electric field for Q2, which is negative charge, it should point towards the charge. So it will point like this, E2. So what do we see here? The electric fields are in the same direction. That's not possible. That means it's not possible to cancel them out. So E net will not be 0 in section 2. So the only option left is section 3. Okay, that's a possibility because it's closer to Q2 and it's far from 4Q. So it's possible that electric field can become equal to each other. We need to ensure whether they are opposite to each other or not. So I'm going to label a point here. Let's label a point R here. Okay, so Q1 is positive. So the electric field for Q1 is outwards like this, E1. Q2 is negative, electric field should point towards Q2, that's E2. Okay, always I'm checking, is it a positive charge or a negative charge? For a positive charge, electric field will point outwards, that's why you have E1 outwards. For a negative charge, electric field will point inwards, that's why we have drawn E2 to the left. We can see that they are opposite to each other, so it is possible to cancel out the electric field, and this is a true sentence. Yes, it is possible. At somewhere, it's saying it's somewhere on x-axis. Yes, somewhere on x-axis it is possible to get electric field, net electric field as 0.